Hello everybody, I'm Rabi Labi from World of Maths YouTube channel. In this video I will prove to you step by step that the square root of 2 is irrational. I'm going to do this by contradiction. The proof by contradiction is set up by assuming the opposite of square root of 2 is irrational. Let's assume the opposite. Let's assume that the square root of 2 is irrational. That implies that exists A belongs to Z set and B belongs to Z star set, that the square root of 2 is equal to E over B and the ratio E over B is irreducible. Z star set is the Z set without 0. The ratio E over B is irreducible. That means that E and B have no factors in common other than 1, or another way of saying is that E and B are coprime. A ratio of two integers is irreducible where they no longer share any factors. If you can write anything as the ratio of two integers, then you could obviously simplify it further. Factor out any common factors to get it to a point where it is irreducible. So I'm going to assume that the ratio E over B is irreducible, and this is important for setting up our contradiction. So I'm going to assume that the ratio E over B is irreducible. A and B have no factors in common, and they have no factors in common other than 1. So what does that do for us? We have square root of 2 is equal to E over B. Let's square both sides of the equation. So if you square the principal root of 2, you are going to get 2, and that's going to be equal to E squared over B squared, and we can multiply both sides of this by B squared, and so we get 2 times B squared is equal to E squared. Now, what does this tell us about E squared? Well, E squared is some number B squared times 2. So anything times 2 is getting to be an integer. We assumed B is an integer, so B squared must be an integer, and so you have an integer times 2. Well, that must give you an even number. That must give you an even integer. So this E squared must be even. So this tells us that E squared must be even. Now, why is that interesting? Well, E squared is the product of two numbers, or is the product of the same number. It's A times E. So this is another way of saying that A times E is even. So what does that tell us about E? Let's just remind ourselves. We are assuming E is an integer. E is either going to be even or odd. We just have to remind ourselves, if we multiply an even times an even, we get an even number. If we multiply an odd times an odd, we get an odd number. So we have a number times itself. We got an even number. Well, the only way to get that is if that number is even. So this tells us that A is even. And another way of saying that A is even is to say A can be represented as two products of 2 times some integer. So let's say some integer k, then we can rewrite this expression indicated by star as 2 times b squared is equal to 2k squared, and then we can write that 2 times b squared is equal to 4 times k squared, and then you divide both sides by 2, you get b squared is equal to 2 times k squared. K squared is going to be an integer. You take any integer times 2, you are going to get an even number. So this tells us that b squared is even. Well, if b squared is even, by the same logic we just used, that tells us that b is even. That is to say that they both have 2 as factor. Both a and b have 2 as factor. We assumed in the beginning that a and b have no common factors than 1, and we found in the end of our work that a and b have 2 as factor. So here is our contradiction. Square root of 2 must be irrational. We will happy to join us on World of Maths YouTube channel. Please like it, share it, and subscribe on it. Also, please visit my website and my Facebook page. Our links are written on the description. Thank you. Bye.